Good morning, ladies and Jose. Welcome to Precalculus class in room 15, where learning never ends, even when Bryce isn't with us. But we hope you'll be here tomorrow and stay caught up. Do you make them stay caught up?
Yes.
So you can't get away without being caught up. All right, that is really some. That's what Johnny Cash would say, because you're mine, I walk the line. Does Bryce walk the line?
Yeah.
All right, very good. I like that. Okay. Now, to me, 25 through 28 are kind of strange.
Why?
Well, okay, I'm just looking at 25 through 28. I'm going to look at these, kind of go through these quickly, what they are, and then kind of compare. And 29 through 40 are also evaluating a calculator. But what makes 25? Why do I think they're kind of strange?
Because all you do is put in Secant.
Okay. Well, here's the reason I think it's strange. I know I'm trying to get you to read my mind, but it says evaluate using a calculator, yet what do you notice about these angles?
You can just put them as like, well, the first one would be secant pi over 4.
Yeah, exactly, exactly.
Second one would be pi over.
Yeah, and so what happens is, for these ones, 25 through 28, these are all standard unit circle trigonometry points, right? Pi over 6, well, pi over 6 isn't one of them, but definitely pi over 4 and pi over 3, right? And so do you really need a calculator to do these?
No. Is it not asking for like the decimal point?
Well, that's one thing about it. It could be decimal point. I'm going to see the way the book articulates it, but then I'm going to go ahead and do number 25 without a calculator. I'm going to see what the book says on that one. In fact, Jose, you can see in the book there, because they'll give you an answer to that. Jose will take a look at that one. See the way they answer it. I'm going to see if they answer it as a decimal, or they, to me, I'm going to consider it, since we can do these without a calculator, let's go ahead and try to do it without a calculator. That's my. So anyway, for 25, we want secant 45 degrees. So what I'm going to do is just kind of draw a 45-degree angle like this. So I try to draw a more or less even type of diagonal that goes like this. And so you have it like this. So that is sort of 45-ish looking, you think?
Yes.
Kind of, yeah, 45 degrees. So here's our 45-degree angle, and what is secant going to be?
The reciprocal of sine, or cosine.
Reciprocal of cosine. So it's going to be hypotenuse over adjacent. So let's go ahead and, so the hypotenuse is going to be what for this one? I want to go ahead and look at the Acp Formula Chart, right? Here's the Acp Formula Chart. So what do we have for 45, 45, 90? We have x squared root of 2. So we come here, we're going to say x squared root of 2. Does that make sense?
Yes.
So now we go ahead, so secant of that is going to be our hypotenuse, which is
X square root
of 2 over
X.
x, which simplifies to square root of 2. And so that's going to be our secant of 45 degrees. Now we get to what Jose was checking on. So it's going to be that or 1.41 something, right? Which one do they give in the book?
It uses at the square root of 2.
Do they just say square root of 2?
It just says square root of 2.
Okay, yeah. To me, that's a better answer. But if you did it with a calculator, this is what it would look like. I'll show you. And again, it's we know secant is 1 over cosine. So in a calculator, we're going to put this as 1 over, but we're in radians here, right? Let's change that to degrees. Mode. Degrees, okay, we changed to degrees now. So we have 1 over cosine 45 degrees. Yeah, 1.414.
Yeah.
Now, one thing that I want you to do is, so if you actually did it in the calculator, that's what you get. Now, one thing I want you to be familiar with, when it comes to, sometimes you're going to answer something and you say, what is it really? Whenever I see 1.414, I know that that's square root of 2. Why do I know that?
Do you memorize this?
Because I memorized this over the ages, right?
Over.
And I know that 1.73 is?
1.73.
1.73 is the square root of 3. I knew that. I know 0.866 is what? Or 0.867 is what? I know it's the square root of 3 over 2.
That's a very random one.
Okay? It's not random. These are all on a unit circle.
Oh, okay.
So it's not random. I know that square root of 2 over 2 is 0.707. I think it's 0.707. So let's look at that.
Yeah, cosine is secant and cosecant is sine. It's also the one you pick.
Cosecant is sine.
Here's square root of 2 over 2. There it is, right? I knew all those, didn't I?
Yeah, good for you.
Yeah, I did that. But
Good.
what it is as you get more familiar with using the calculator, going back and forth between using a calculator or not using a calculator, gradually over time you're going to accumulate what?
Knowledge.
Knowledge, remembrance, kind of I call it sometimes a mathematical type of intuition almost. What you expect and what you get. So anyway, that's, and I'm sure you see things, okay? All right, good work. So what I want to do is call on somebody to help us with with our subsequent problems here. Sine 60 degrees. If I did this in a calculator, I know though I would get 0.866. Right?
Yes.
But it's not 0.866, it is, and you don't come on somebody.
Is the house on the
What?
It's the, oh yeah,
Yeah.
and then, x and x the square root of 3.
Okay, for this one we have at.
How do you know where to put what, like the x square root of 3? Do you know where?
You just remember, yeah, 2x, 2x is always down there, always. And then x square root of 3 is a little bit straight up and down. And then x is the one that goes.
Oh,
I think you just have to
How
do it out.
great.
3 types of triangle, right?
well, there's 3 types, but for this one, there's 1 type. You have
There's 2 special right triangles.
I don't even think we can do it.
Are you sure that x square
Is sine or is it or how much smaller would you do?
Wait, sine is also.
Victoria,
Because she never really explained.
we had some problem with Sarah earlier today.
We did.
Yes, we did.
doesn't matter.
The internet was down during first period, yeah. The wireless one. Now, I give Sarah credit in that the internet that plugged in was good. It was the wireless that was off for a while, so. But that was only during first period. By second period, it was all good.
Oh, she did a good job.
I actually got it, but, you know, nobody's perfect. Nobody's perfect. I'm sure she's working hard at it. I appreciate her.
Mr. G, I have a question. How do you know, I understand that 2x is always the hypotenuse for 30, 60, 90 triangles,
Yeah.
but how do you know which side x goes on and which side x square root of 3 goes on?
Okay, that's a good question.
Okay, the bad handwriting is the board's fault.
I didn't get that.
I thought.
Did y'all switch X squared?
Yeah, did y'all switch,
Yeah.
y'all switched them? See, that's why I'm confused.
I only got.
Do you know why you
You know what? Let me tell you what I think. This is what I think she did. Well, because the reason is,
Me too.
shouldn't 60, if 60 goes down here
Oh,
and 30 goes up here, then everything's going to be fixed, right? So, I want you to go ahead and put these angles in the right place.
So why does it need to be on the bottom?
if
you
you
do
just
that?
move the X square root of 3 and the other thing, it's the same thing as moving the angles.
I'm just confused. I'm just.
So the 60s are going to be the X, right?
It's over, I guarantee she's not the only one who made that mistake.
Mr. G, so this is the same thing, right? Because she has to switch these two, which means that these two are in the correct position.
Oh, whoa.
Yes, she
So now what?
Is adjacent to x.
It would be 1 over
But that's how
square
it's
root of
correct, right?
3.
That's what I'm saying.
Oh, I'm sorry.
Yes.
I thought it was square root of 2x.
Yeah,
that'd be
that's
X.
60.
Yeah, it's 60.
Yeah.
X square root, I didn't know you switched it.
2x is the hypotenuse.
Right, which I don't even know why she.
Do you always just think that 60 is adjacent to x?
I look at, because on the
Yes.
thing, because it has 30, 60, 90, x next to the power.
Okay, so you just like.
So,
correspond them.
pretty much so like
She
the 30,
as like it's opposite.
yeah, 30 is opposite of the x.
And I'm also going to introduce the hand trick today too, to help you with this too, where you could just look at your hands and get it right.
Square root of 3 or 2? But if it's like this, then 90 is it?
Okay, I want you to look at the
On the other side.
unicircle trigonometry mug,
That
right?
means it's not.
Unicircle trigonometry mug. See that? So you got that left hand out there
On the
like
90,
this,
you
right?
have to be 2x.
Okay.
No matter
You
what.
see that?
Well, it's almost right now. Originally, they're going up with sine.
No, it's because it's
This is what I did,
Over
but
hypotenuse.
What is it?
You see
But
that?
they were saying.
Sine's
isn't it
opposite of
also
hypotenuse.
Oh.
It's because, hey, it's because it's the hand.
So x square root of 3
The 68 can take
over 2x.
Two x.
Yeah.
It's because
cancel out?
Yeah.
So she missed
So
the
it's just this.
Square root of 3.
Yeah.
because she had this at the same position and then this position.
That everybody does every day.
She just
Here,
was
we're going to do this.
Over at 2?
Yeah.
Here, you can have it for the day.
Oh, no, it's okay.
You can have it just a little bit more because it's been
That's why
by
it came out so
the
long.
computer.
Then you tear them right. So
Yeah.
the second thing is always.
Think about porcelain.
Oh, yeah.
When you're
It
gonna
holds
use
heat
this
a
type
little
of
bit,
paper,
right?
always put them.
That's what helps keep your hot chocolate hot.
And then keep, put your 60 up here. Keep it there, you know.
Okay,
Okay.
all right, now is it right? Okay, good, good. And I want to go ahead and tell you, this is part of your unicircle trigonometry song.
Okay.
Okay. 0, 1/2, and square root of 2 over 2, that's what I'm telling you. Square root of 3 over 2 and 1, so that's it, 60 degrees, right? And 1, the sine is the height at any radian. The square root of 4 over 2 is 1. 0, 34, 5, 16, 19.
That's
That's why I love you in trigonometry. 0, 30, 45, 16, 19. That's why I love you in circle trigonometry. So that's it. So we have that. And the way this works with a hand trick, Lexi has the cup there. And what it is, you go like this and you take the fingers like this. And what this is, if below the angle you're looking at, which right here is, this is pi over 3 right here, you extract that finger and your sine is going to be square root of these fingers over 2. And so that's going to be square root of 3 over 2. There it is. And your cosine is going to be square root of fingers above over 2. So cosine is going to be square root of 1 over 2. Over 2. Okay, all these are going to be over 2. And the tangent is going to be sine over cosine, which is going to be fingers below over fingers above, or square root of fingers below over square root of fingers above. So the tangent of this is going to be, what's going to be your, how many fingers do we have below? 3. How many do we have above? 1. So we got square root of 3 over square root of 1. And what's that simplified to? Square root of 3. So our tangent of this is going to be square root of 3. And so you have all these numbers working together. You have these tools, including the hand trick, including the unit circle trigonometry song. And so, and I gave you a copy. You have the unit circle, right, in yellow or orange. I gave it to you yesterday, right? So you have that. What I want you to do is try to do this mentally as much as you can, and then you can look at your unit circle, see if it makes sense. All right?
Right.
So you're trying to build your fluency in a whole new language, aren't you?
Yeah.
With this. That's what we're trying to do. And this is another language, isn't it?
Yeah,
It really is. When you talk about radians and
it is.
degrees, minutes, seconds, and all kinds of stuff. Okay, next we have 27. Again, it's a square root of, it's a pi over 3 thing here.
Can you teach me the hand thing?
Okay, we have, for this one, we have CF,
Do you want to see the book?
CF, CF,
It
CF.
explains what you just explained.
Square root of 3.
How does he know?
Oh, wait, no, we're on-
What's below?
We're on 27?
Like,
27,
on the
Oh,
last one,
it's
it's 60 degrees.
2 over the square root
So
of
you
3.
put down
2 over
the
square root of 3,
pi
okay.
over 3.
Oh.
Over 3. And so it's 1 over 3?
My bad, I thought we were on 28.
Well, it depends what you're finding. If you're finding the sine,
Okay.
cosine, or tangent.
What if I want to find sine of 60 degrees?
You get
This
2
is
x
60
on the
degrees.
first time. It's like, oh,
square root
it's
of
So CF says she gets 2 over square root of 3, is that what it was? 2 over square root of 3?
Yes, that's what it says.
2 square root of 3.
It's always his finger.
Okay, Jose, what does the book say for number 27?
Okay, so for
For
sine,
cosine, it's fingers above.
for cosine, it's
Three
fingers
fingers
above.
or G?
So cosine of 60 would be 1.
It's weird, because it
Square root
says
of
square root of 4 over 3, and then
Over
it
2.
equals to 2
Right.
over square root of 3, and then it equals to 2 square root of 3 over 3.
Yes, square root of.
Okay, so different ways of saying. The second one is what she said, right?
Now,
The second one is
tangent
Yeah.
of 60 degrees.
And the third one was a rationalize, getting that square root of 3 out of the denominator. So it can be 2 square root of 3 over 3, or she said it could be 2 over square root of 3. So let's look at that quickly.
How did you get to?
So she has the,
Over
A
2?
cosine 60.
okay, so she has the,
Of
3.
3 over 1.
she has this here. She has the
You don't do this.
pi over 3 right here.
Why?
That's our pi over 3.
Then it's just.
This
says
is our
over 2.
cosecant. So we're going to have 2x here.
Okay.
And it's going to be 2x over, this is gonna be
So.
x squared root of 3,
Yeah.
and this is gonna be x here. So cosecant's gonna be 2x over x squared root of 3, and cancel that out, so we get 2 over square root of 3.
5 or 6.
Okay, to rationalize it, you just.
Sine.
And rationalize it,
5 or 6 is working.
if you rationalize it, multiply by square root of 3 over square root of 3.
Right.
5
And
or
we're
6.
gonna get 2 square root of 3
I would
over
like sine
3.
of pi over 6, so that's
That's a rationalized one version of
30
it.
degrees.
Okay.
Wait, Mr. G, can you have
So,
in the 30
that's
and the 60
square
and
root
the
of
triangle,
3
like,
over
can
1?
you put the angles in?
Or is it just square root of
pi
3?
over 3.
That's what I thought, but
Trying to
it's not
find-
making sense to me, because I'm.
Yeah, let's go ahead and do that. So this is a,
At the top.
this is 60
Cosine
degree.
is above.
I draw it on top, he draws it right there.
Below,
Here.
over,
This is
over
the
the
line.
And I have a reason for drawing it like that too.
60 on top.
Let me tell you, there's a reason I draw them like I do usually. I will show you
Oh,
that
and
reason.
it might be.
Okay, yeah, I am.
Okay.
Because I'm drawing it the same.
Do you see these drawings over here of these,
Because you could write 60.
you see these posters over here, Mr. Calvin got these years ago? What happens is by convention, in standard position, angles start here along the x-axis.
Yeah.
And so when I draw a triangle, usually I draw it with that type of convention, so that the angle is going to be right here, going up to here in this case. Now, by the way, that gives a 60-degree angle, doesn't it? So,
Over 2.
so
So
anyway,
always
that's,
gonna be in that quarter of a triangle though?
yeah, and also this brings up the question of something called a reference angle or reference triangle, which we're going to go into
Square root of
in section 4.3 of our 30 next week. Okay?
square root of 2
I draw
over
the same on that one there. I'm gonna start drawing it
All right, I'm going to call somebody for number 28 in just about 2 minutes.
2. And it's above.
What numbers do you have?
Why is it always over 2? Why is it always over 2?
Doesn't matter where you put this one, you have.
Okay, what's Mr. G?
That's
When you're doing
Square root of something over 2
Yeah,
for sine and cosine?
yeah.
How come it's over 2?
Yeah.
And sine is hypotenuse over adjacent?
No.
Well, the easy answer to that question is, the reason it's over 2 is because it works.
Oh.
Okay,
Now
so
that's-
it's just
It just works, I don't know if it's by, that's just the way it works out. Because if you look at all the sines and cosines, they are all over 2, right?
Or like if you're doing the third column.
Because cosine and sine are both above hypotenuse.
Yeah, because pi over 4
Oh, but
is you have square root of 2 over 2, and then square root of 2 over 2 are both the same.
Is it the same for those 30, 60, 90
See, I think that's the hardest part, is making sure you have the right,
Hypotenuse
like,
2x.
sine, cosine, and everything, like, you're doing the right formula for it, like, yeah.
Then I don't need to.
Just write this, sorry. Well,
So I
I
understand your
put the X,
explanation for
and then I put like.
30, 60,
Yeah.
90.
That makes
That makes sense to me.
I don't know.
Maybe it's because it's square root of 2.
Okay, for number 28, we have,
I think it's just quicker for me, because I have to look at it and be like, I'm gonna like this.
okay, we have plus.
Hey, it's your turn.
The adjacent.
What?
This is your turn.
Yeah, it's
We have
Yeah,
plus
that's just not-
for this one,
that's not-
plus.
Do I have it going?
Yes.
You had it, like,
You got your X and X sort of thing on place. You got the right answer though.
How do I get the right answer?
You didn't do.
I didn't do the one?
Yeah.
Oh,
still
happy
the right
accident.
Can you paint us a picture of them?
I'm going to draw a big triangle, okay?
Oh my god. This is the mountain that the goats get thrown off of.
She wasn't
Oh my
kidding,
gosh,
was
I
she?
forgot about that. What class did we watch that video in? We watched that at the beach. With Bristol. That was hilarious. Did you take things?
Oh, man. Mr. G, I'm struggling with this board.
Bristol McCartney.
What? Opposite Bristol McCartney.
Oh, man.
The other way around.
Oh, that hurts. Drink that on your way.
Okay,
Two class,
what
three this class. No, my ribs go out.
What are you looking at?
Are you talking to me? We'll stop.
So this is my final answer.
Eagle sign.
Oh my gosh, why is it flying?
Oh, this equals.
The eagle's going to get the As a hop, it's an eagle or a hawk.
Okay, the thing is, here's the thing.
Could you imagine
The thing is,
looking in the, like the map, it's all just.
What- the only thing I have, because she was big, right?
You did
But then, so since she goes down here, here's your opposite, this is gonna be x squared 3, right?
Yep.
Right.
And this side over here is gonna be x.
Right.
So she's got x squared 3 over x, and that's where she has, it, right? Equals, which is tangent pi over 3,
It's something
Yes.
above or below.
that, okay?
Below.
Square root of 3.
Below, above.
And then,
Below, above.
the hand trick, right? Tangent is square root of these fingers over square root of these fingers.
Yes.
Square root of 3 over square root of 1 is,
Ask if I
square
can
root of
see
3.
the radius for this.
Okay, the next ones here are really legitimate calculator ones. So,
Mr. G, do we have to be in radians or degrees?
it depends on, I'll tell you what it is. I'll tell you, most of the time I recommend pre-calculus students have their calculator in degrees most of the time. Now you can switch to radians depending on the situation. Like for for this one 33 for instance, you can change your calculator into radians and then just enter it, right?
But for 29,
But
it needs to be in degree.
Well, these one right here, so sine of, that's going to be easy because you can button your calculator. I want to show you one where you don't have a,
Do you just literally plug it in, Mr. G, and get the answer? For like 29?
like secant 49 degrees, for example. What I would do for that one, make sure we're in degrees.
29 is 0.
So secant of, I'm just going ahead to 35. So secant of that is going to be, that's going to be equal to 1 over cosine 49 degrees, right?
Eagle versus goat.
So you go here, 1 over cosine 49 degrees, 1.524, right?
Got it, Mr. G.
So that's 35 worked out, okay?
We skipped a bunch, Mr. G.
Yeah, we did, and the reason I want to skip ahead to this one because this is one that's a reciprocal ratio.
Yeah.
I just wanted to show you how to do that. These other ones are going to be pretty easy. Like, you can, if you want to stay in degrees, which I would probably do, I would just make this sine of pi over 15 times 180 over pi radians. And so you'd have that, right? So sine of 180 over 15, that's going to be, is that 12?
So if I'm in degrees, it's not this.
Yeah, you have to do those on radians.
12.
Which
Yeah,
one?
180 over 15.
The one where it's like pi over.
Oh,
Is it 0.2?
That's 12 degrees. So I left my calculator in degrees, but I converted this into this pi of 15 degrees. So now I can just take sine of 12 degrees. So sine 12 degrees is going to be 0.2079. So to 3 decimal places, 0.208. So approximately equal to 0.208. So this is going to be our answer to 34. So go ahead and do those other ones. I'm going to call on people and go and put up answers. Can you do that?
Yeah, sure.
I did. I didn't just do what you used to, what I used to.
So I'm going to go back to 29.
What'd you get?
Oh, another thing another tweak here is these degrees, minutes, seconds things,
I would do that one.
but you can figure that out.
268.
So I want you to go, I'm just going to call people to go pretty quickly through this.
How do you say how to do it?
He didn't.
Yeah, I did.
He said we could figure it out.
Oh, okay. That's chill.
Is it
Okay, this one here, number 29, we have GL.
Okay, I got an error, when I tried to put this into the calculator.
So I think that's the end of my math.
3.07.
I got that.
You got an error too?
Oh, I don't
Yeah, can you work that out, please? I am so lost.
Okay, 0.961, right? Is everybody okay with
How
that?
do we get that? How do we get that? You just plug in sine 74.
Yeah, so that's all she did.
No, just sine 74. Well, then why was he doing, that was for when you had letters, the other thing.
So you just go here, you're in degrees, right? So you go to sine. Oops, I got
So are you in degree or? I don't know how to get there. Go to another. I don't know how to do
Sine
that.
74.
And then at the top, if you're highlighted on degree, then you're in degree, if you're highlighted on radian, then you're on radian. Do you see it?
0.961. That's not hard, is it?
Nope.
Okay.
Still got an error.
I think I
Because there's a big.
Yeah, I can tell you that.
Well, you just put, you don't turn
1
second. If you do
Yeah.
second, if you do second sign, it's good. So
Every
just
time it's like
sine.
secant, cosecant.
No, I get that, I'm talking about the .89. Is that a degree or what?
No, it's just a number. I just plugged it in 0.89. So I did 1 over tangent 0.89.
Okay, what did you get?
64.37.
If you just plug it in like you did.
Okay, tangent of 8 degrees. We have for tangent of 8 degrees.
How do we get, how did we do this? Cosecant.
On 1 over tangent 0.89.
Okay, we have for number 30, we have VC.
The answer for 31 is 0.94.
Got it. How do you do these that are like, I can't.
Plug it in 1 over sine 19.
One
Oh,
over.
It
But how did you
does,
do it?
it's a 1
Because I
over.
don't even
You just plug that as a decimal, 19.23.
Okay, 0.141, everybody got that?
What are you
It's a
doing?
decimal.
You just use that as a decimal.
Everybody got that, I hope, right?
So it's 1 over sine of 19.23.
Okay, now, for this one where you have a DMS, the way I would do this is I would rewrite this as cosine.
So what?
I'd write that 19 plus, how do you convert those minutes into degrees?
Is it a, what's cosecant equal to? Sine.
Oh, you combine them?
So I would do it this way, number 31,
Cosecant is sine.
Right.
That's what I just said.
convert those 23 minutes into degrees, and then you would get it, right? So I'll choose somebody here for number 31.
What did you just do? 19 plus 23 over 60? Because of time?
Okay, we have this one here, we have Joe.
So you don't add a decimal?
It says you do it, it's just close enough to where it does that, but I'm guessing since the 60, 100 is kind of close in terms of hundreds, right? So it said you just do plus 23 over.
You're not supposed to be doing this.
Oh, but I want to, I feel so good.
You were jumping off the bleachers as a kid, weren't you?
But they had that step there, it was like,
Yeah.
it was like they didn't have a step, they were trying to sabotage me. But they didn't succeed at it. Except they dropped the poster down on me, you see
Yes,
that?
I was right in front of you.
Yeah, man, it was just-
Yeah.
It just about, man,
Always.
I just about suffocated.
Yeah, it was after second. That's why it was close.
They tried to finish me off there, but they didn't succeed.
Yeah, they covered you in that black poster, they're gonna take you away with it.
Yeah.
0.43.
Okay, we have this next one here, tangent of this. It's gonna be, okay, we have LD. LD, that's you.
I wonder if you could do that. I wonder if you could do that decimal thing and just go down every time. Just go down.
Here's on the next one was 439, and when I did the decimal, I got 439. It's just, it's close enough when you do like, just go to the hundred.
Yeah, it's 43.
One of the tens
No.
places. What, did you get it? Are you sure that's the same? Even though it's 100 degrees, it's just.
That's the one. Oh, I didn't even realize I didn't have a degree. Probably not.
But I don't want to do it. You can still do it the same, but I don't know how to do it with the 0.89. Is it 0.89 or
Maybe they just forgot the degrees.
I don't think so.
What, 37?
Yeah.
That's for 37, that's 8.
8,
0.8.
Yeah.
Okay.
Um,
Thank you for that. That was,
Let's see.
That's it.
LD, okay. Okay, the next one we want to have is KJ. Trying to keep track of everybody.
Switch it to radian.
Oh, we already did this one. I did this one already, right?
Yeah, I'll do 30.
Today's go 34? Yeah, she's gonna do 34.
Okay, what can I calculate?
Oh,
What about it?
Am I doing it wrong?
What I've done,
Any of them, all those are, that's 30, if you scroll up,
That's probably right.
what I've done,
We haven't done
thank
those yet.
you, is I've repopulated the wheel because we've gone through everybody today, right?
Okay.
So
What?
you're
No.
gonna get,
Mr. D, I'm not gone.
you're not done?
I never win.
I have not gone.
Oh,
yes,
yeah,
I have.
but yeah, you did yesterday. You were, the rest of the people were, yeah, so you haven't gone today yet, you're right.
Because of that.
But you're on a fresh wheel, Jace.
Alright.
Yeah, no, that's a good point. She makes a good point. So we already did this one, right?
Yes.
Okay, cosecant 19 degrees. So when you get picked now, you may have got picked for a second time today.
What's the answer for 39, 40?
49 is 2.41.
So,
Wait, how do y'all plug that in if it 1 over?
Okay. Yeah, we have VC
Okay.
again on this
you
one.
should radian.
Yeah, I did degrees.
You did degrees in your calc?
No.
Why do you do times when you
Because when you keep it in the ratio, they got high.
So why didn't you do the same for this one? Why didn't you do pi and 180?
I did, but I just crossed that high,
Thank you.
just got the 5.
You can use this.
It was
You just
still,
did 180 over 10.
yeah, the same thing you did for 180 over 15.
Is that right? So you could have done
Okay,
185.
37. Yeah, the bell ring, that's right.
I just did, I even could have done 180 right.
37, we have plus again.
Which one?
37.
Mr. G, I just did this one normally because nobody knew what to do since .89 didn't have a degree. So I just plugged it in like how I would work it.
Oh, I'll tell you what it is. Yeah, this is supposed to be in radians. If you don't have a thing, you see a number like that. So what it is, it's gonna be that radian. So if you leave it in degrees, it's gonna be the same as cotangent. We have .89 radians. And convert to degrees, you go ahead and multiply by 180
What's that, 40?
over pi radians.
3.236?
Yeah.
So what it is, these cancel out.
I got
So what you
negative.
do is it'd be cotangent
I got what you got, Chloe.
of .89
Are you in radians?
Yeah.
times
What'd you put in?
180 over
1
pi.
over sine 18.
18.
Oh my god.
If your calculator's still in degrees, right, because you convert to degrees, there you have your answer.
I literally put it in how it is. Hi, Mr. G, are we turning this into you?
Is it,
Are you finished with it?
Yes,
It's
yes.
30, hey, what'd you put 30 in?
Okay, yeah, I guess you can turn it in.
I'll still get a negative.
Let's get it for you.
Yeah, if you didn't do 4. If you didn't do 1 or 2 at the end, that's okay.
Oh, 3.268.